Welcome to Chapter 2. This is Section 2.1, where we're going to expand our ability to use trig. And it's called Trigonometric Functions on Acute Angles. And we're going to look at some very special angles that we're going to have to memorize. Their trig can exist on a whole bunch of angles, but we have a few that we want to focus on. And what we'll find is that because of some properties of triangles and things like that, we will be able to just get by with just a few memorized ones and handle everything that they expect us to have memorized. So what we want to remind you of, I think I've mentioned it before, or at least point out, is that we have right triangle trigonometry. And so the right triangle trigonometry says sine is opposite over hypotenuse. Okay, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, I'm not going to say any more about cosecant, secant, and cotangent, because if you know those first three, then you just flip their corresponding one in order to get them. So at the bottom here is the word, well, it's not really a word, but an acronym, SOHCAHTOA. So, sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA. And so in example 1, what we have is a right triangle that's given. It satisfies the Pythagorean theorem with all of those. And they just want to make sure that we understand this definition, so no problem. They want to find the sine, cosine, tangent for triangles A and B. So let's focus on A. And they just want the first three, so sine of A. Let's find A. A is right here, right? Here's A, but there's the angle A. And sine A is opposite over hypotenuse. And I don't believe that that reduces. Cosine of A would be the adjacent side. So the side adjacent to A that's not the hypotenuse is the 77. So that's going to be 77 over 85. And then the tangent of A. The tangent of A is opposite over adjacent, and the adjacent side is 77, and we're finished. So that dealt with angle A. Now let's go get angle B. We'll do that in red. And so sine of angle B is the opposite side, which happens in this case to be 77 over 85. So notice something, that the cosine of A and the sine of B match. That's because they are complementary angles. And it's one of the reasons why cosine is called cosine, is because it's a cofunction of it, which we'll define in just a moment. Cosine of B is adjacent, which is 36 over 85. And notice the sine of A and cosine of B are the same. And then the tangent of angle B is equal to opposite over adjacent. And we're finished. So it could be just like that. And so here's where they're noting what I pointed out. Note that sine A and cosine B and cosine A sine B are always true for, and that's always true for acute angles in a right triangle. And we will be able to get by with just acute angles. So since angles A and B are complementary and sine A equals cosine B, sine and cosine are cofunctions. And that's why it's called cosine, is because it's the cofunction of sine. So for any acute angle A, cofunction values of complementary angles are equal. So sine of A is equal to cosine of 90 degrees minus A. So, we'll watch this happen. Cosine of A is equal to sine of 90 degrees minus A. Secant and cosecant secant and cosecant are cofunctions of one another, and tangent and cotangents are also cofunctions of one another. And so they want us to put this into action. They want us to write each term in terms of its cofunction. So sine, let me go back to blue. Sine of 9 degrees. Well, its cofunction is cosine, but it's not going to be equal to the cosine of 9 degrees. It's going to be equal to the cosine of 90 degrees minus 9 degrees. That's what that's saying. Or the cosine of 81 degrees. Done. You have written it in terms of its cofunction. How about cotangent? Its cofunction is tangent. 90 degrees minus 76 degrees is going to be 14 degrees. So the cotangent of 76 will be the exact same value as the tangent of 14 degrees. And the cosecant of 45 degrees is going to be the secant of 90 minus 45. You put degree symbols in there in case that's driving somebody nuts. And we're going to get a nice 45 degrees back out because that's exactly half 90. And then they're just going to make sure our algebra skills are good. And they need to be really, really good. So if you've chosen a major that will totally respect the fact that you have chosen it, and therefore assume that you are really, really, really good with your algebra. So be careful. So as we look at this, the cotangent of theta minus 8 degrees equals tangent of 4 theta plus 13 degrees. We got a little bit of a problem. And the problem is that I don't have the exact same trig function working. And so we got to change one. So for lack of a better one to change, I'm going to change the one on the left. The cotangent, I'm going to change to tangent. That way it will match this other one. But I can't just say it's of the same thing. It's got to be of 90 minus theta minus 8 degrees is equal to tangent of 4 theta plus 13 degrees. So the nice part about that is when I do this, I can set the inside pieces equal to one another. If tangent of one is equal to tangent of the other, and I know that both are acute angles, that's a huge statement right there, that they're both below 90 degrees. None of these cofunction relationships would work unless the angles were acute, right? And so we gotta pay attention to every part of the definition. So ideally what I would do right now then is set the angles equal to one another because they would absolutely have to be the same and then solve. But here's what's going to happen. I'm going to get the wrong answer. I've done something majorly wrong, something that you said you would be careful of when you chose this major, whatever major requires you to know calculus. Do you see what I've done wrong? Okay, I'll show you. I'll put it in red. It's 90 degrees minus the entire angle. If you don't subtract both the theta and the negative 8 to get the positive 8, you're going to get the wrong answer. So you have to be super careful. There is no such thing as simple mistakes. It's algebraic breakdown when that stuff happens. And that's a problem that you want to identify and fix. And so instead of having 82, we're going to have 98 degrees minus theta is equal to 4 theta plus 13 degrees, right? We're going to have 85 is equal to 5 theta. And we're going to get very quickly theta is equal to 17 degrees would be the right statement here. So be very, very careful. Subtract away the entire thing. In this case right here, on this other side, I'll model it by solving for the other one. So I'll leave the left-hand side alone. Secant, it wouldn't matter which one you change, by the way, is I guess what I want to stress. And this would be the secant. And just remember, be careful, theta minus 2 theta, and then minus a negative 8. Oh, not theta, apologize. And let me give myself a little bit more room. So if you're okay, I'm going to not try to sandwich myself into this side area. I'm going to erase this since you can back up over the video and see it. And we'll give ourselves a little bit more room here so that we don't have to write stuff small. And so we're going to leave that first one alone. Secant of 5 theta plus 14 degrees, we're going to leave alone. And we want that equal to the secant. And we got to use its cofunction relationship, 90 degrees minus 2 theta and minus a negative 8 is plus 8 degrees. And again, we get a 98 out of this. So this is 5 theta plus 14 degrees is equal to 98 degrees minus 2 theta. That means 3 theta is equal to 84 degrees, and so theta is equal to 28 degrees in there. And we're finished. Now, it wouldn't have worked out if we didn't distribute that minus sign, and so that's the biggest thing that you want to be careful of. So now they want us to determine whether the following statements are true or false. They really like us to think about what's happening here. So let's think about tangent. Tangent of 25 degrees. Everything can be argued through the quadrantal angles. So tangent of 0, tangent sine over cosine. Sine corresponds to y, so that's 0 over a number, but let's say 1. And so that's going to be 0. And then when you come up here, it's undefined, right? Because up on the y-axis, the y value is 1, but the x value is 0, and we're going to get undefined. And so what's happening here is tangent is getting bigger as we go this way. So let's look at the relationship. Tangent of 25 then should be bigger than tangent of 23, because here's tangent of 23, here's tangent of 25, should be getting bigger as we go this way. This one is false. How about cosecant of 44 degrees and cosecant of 40 degrees? Okay, let's see what happens. Now, cosecant is the flip of sine. If I think about sine for a minute, sine starts at 0, right? Sine corresponds to y, so its flip would start at infinity or undefined. And then it would go down, and sine here is 1. As we saw before, sine of 90 degrees is 1, so we are falling. And so where is cosecant of 44? And cosecant of 40? That seems like a true statement then, right? That cosecant of 44 would be less than cosecant of 30. So we got some special angles that we care a lot about. These are the only ones that you have to have memorized, but you need them memorized. They will be called upon later on in this class, and you want to have very instant type of recall over them. They will also be just brought up at random in subsequent classes, especially calculus. We do a lot of changing of things into trig because the trig makes it easy. And so you want to memorize your special angles. So far, we would love for you to have memorized what the cosine of 0 degrees is, or 0 radians. What the sine, cosine, and tangent are of 0 degrees or 0 radians. We would like you to have 90 degrees, 180 degrees. So 90 degrees is pi over 2. 180 degrees is pi. And we would like you to have 270 degrees memorized, which is 3 pi over 2. We would love for you to quickly be able to figure out, like we did here, that the tangent of 0 degrees is going to be 0, that the sine would be 0 and the cosine would be 1. That at 180, the sine would be 0 and the cosine would be -1. That at 270, the sine would be -1 and the cosine would be 0. Those are the things that we'd love for you to be able to write down. Don't skip the memorization. You need it. I remember a student coming to me years ago saying, Jensen, this is the 3rd time I've taken calculus. I don't understand why I'm not passing. And we figured out that it was really because he didn't have his special angles memorized. He's like, I can't do it. And I said, well, you just got to sit down and do it. And so let's look at it as 2 specific triangles. So this is 90 degrees. And this is 90 degrees. Now they have this triangle over here. But I want to take a look at this guy here. So, apologize for the hesitation, just making sure that this is a good way to go about it. I'm going to call this small angle here 30 degrees, and this one here 60 degrees. They would have to be 30 and 60 because the total amount of angles in a triangle, if you sum up all the angles, it better be 180. If you have a 30, 60, 90 triangle and you let your hypotenuse be 2, let me show you why you absolutely know that this side would be 1. So if I let this triangle have side 2, and I drop a perpendicular straight down the center, what I've done is cut this angle. We're all 60 degrees down to 30 degrees. I have two 30-degree angles there. Well, if I cut it directly in half, this is 1. So we know that's 1. And if you use the Pythagorean theorem, you'll find out that the height of that triangle is root 3. That's our picture. And if you look at your SOHCAHTOA, you can figure out the sine, cosines, and tangents of each one of those. But let's take a look at them. Sine of theta, well, let me not put theta, apologize. Let me put 30 degrees. Sine of 30 degrees is opposite over hypotenuse. Cosine of 30 degrees is adjacent over hypotenuse. And tangent of 30 degrees is opposite over adjacent. And then we would just flip them to get the other 3 that are in there. Okay, so that's one of the triangles. The other one, I'm going to make this one look a little bit better. The other one comes from these two sides being equal to one another. So this side and this side being exactly the same. And what you would have if that's the case is you'd have two 45 degrees angles in there. That would be a 1, and a root 2 in there. So the sine of 45 degrees is opposite over hypotenuse. And they'll always rationalize the denominator. Cosine of 45 degrees, opposite over hypotenuse, which is also root 2 over 2. So at 45 degrees, the sine and cosine equal one another. That should make a lot of sense because if you look at 90 minus 45, you get the exact same 45. And then tangent of 45 degrees is equal to opposite over adjacent for 1. I forgot something in the above triangle, and I forgot to look at the sine of 60 degrees. Sine of 60 degrees would be opposite over adjacent. So notice sine of 60 and cosine of 30 are the same. We're not going to be surprised to see that cosine of 60 degrees is the exact same as the sine. And the tangent of 60 degrees is the flip of the tangent here, or root 3 coming through there. So we're looking at some very specific angles, but I promise you they're the only angles that we need to memorize. So we've taken our 3.11, part 1, and put it together with the degrees here so that we have all the different degrees, both in radians. And this is everything I need you to memorize. And so memorize it. Sine of 0 degrees is 0. Cosine of 0 degrees is 1. Tangent, sine divided by cosine is 0. And then just flip. Undefined, 1, undefined. Pi over 6. Sine of pi over 6. Sine of pi over 6 we saw was 1/2. Okay, so if I draw that angle down here and call this one the 30-degree angle, remember it was 1, root 3, and 2. The smaller side, so just remember 1, root 3, and 2 are all connected. Opposite the smaller side is the smallest side, or smallest angle is the smallest side. So opposite the smallest angle is the smallest side. And then opposite the 60-degree angle is the smallest leg of the largest leg of the triangle coming through there. So you'll get it memorized. So sine of theta is 1/2. Cosine of theta is root 3 over 2. Tangent is sine divided by cosine. That root 3 would end up on the bottom, so this is a root 3 over 3. And then just flip. Flip 1/2, 2. Flip 2 root 3, flip root 3 over 2, 2 root 3 over 3. Flip root 3 over 3, and you're going to get root 3. 45 degrees, or pi over 4, root 2 over 2, root 2 over 2, 1. Flip it for root 2, flip it for root 2, flip it for 1. So hopefully that's not too fast. We're getting those from the above. What I have memorized is that sine of 30 degrees is 1/2. Sine of 45 is root 2 over 2, and that's all I need. Because I know that with 1/2, the corresponding other result is root 3 over 2, I just play around with those. So for example, if I were asked to do the sine of 60 degrees, I would think, well, I know the sine of 30 degrees is 1/2, so 60 degrees is the other one, which is root 3 over 2. That means the cosine is 1/2. And then I just think, oh, sine divided by cosine would leave a root 3 up top. This is the root 3 one. And then I would just flip. And coming through. Pi over 2 or 90 degrees. I would draw myself a picture. Hey, here's 90 degrees. Sine corresponds to y. Okay, that's 1. Cosine corresponds to x. Okay, that's 0. Tangents, sine divided by cosine. 1 divided by 0, undefined. Cosecant's the flip of sine, 1. Flipping 0, I get undefined. Flipping undefined, I get 0, is what I would think there. Then for pi, I would draw myself a picture if I didn't have it immediately memorized. Remind myself that sine corresponds to y, 0. Cosine corresponds to x, -1 direction. Tangent, sine divided by cosine. In this case, it's 0. And then flip everything, undefined, -1, undefined. And then root 3 over 2, where would that be? That would be down here. And I would remind myself, sine corresponds to y. So I'm going in the y direction, -1. I'm going out none in the x direction. Tangent, sine divided by cosine, undefined. Flip -1. Flip 0. Flip undefined. And I'm talking you through it because that's literally what you can do every time, is flip right through those guys. Okay, still in this 2.1 section then. They want to have you have by memorization. So remember, I have memorized that the sine of 30 degrees is 1/2. The cosine of 30 degrees then would be the other one, which is root 3 over 2. You can memorize these. Tangent of 30 degrees would be sine divided by cosine. So let me show you what I mean. Sine divided by cosine would mean when I go to figure it out, the root 3 is on the bottom, so this is going to be the root 3 over 3, the rationalized one. And then for the corresponding ones, I just flip. Let me get rid of that equal sign. I'm not sure why I wrote that. So for the corresponding ones, cosecant of 30 degrees, which is the flip of sine, 2. Secant of 30 degrees, which is the flip of cosine, 2 root 3 over 3. And tangent of, cotangent of 30 degrees would be the flip of root 3 over 3, which would be just a plain old root 3. And now for 60 degree angles, when I went to go get the sine of 60 degrees, I would say to myself, well, I know the sine of 30 degrees is 1/2, so the sine of 60 degrees is the other one. And that means then the cosine of 60 degrees is 1/2. And you can use whatever language helps you out the best. And here, if I take the root 3 over 2 and divide by 1/2, my root 3 stays up top, so I know I'm going to get a root 3. And then I just flip. Cosecant of 60 degrees is equal to 2 root 3 over 3. Secant of 60 degrees is equal to 2. Cotangent of 60 degrees is equal to root 3 over 3. And then 45. And so the point of these exercises is to stress the memorization. Sine of 45 degrees, it looks like 450. Sine of 45 degrees, well, that's the one that's the same, so that's the root 2 over 2. Cosine of 45 degrees, also root 2 over 2. And tangent of 45 degrees is equal to 1. And then the cosecant of 45 degrees, root 2. Secant of 45 degrees, also root 2. Cotangent of 45 degrees, 1. Now this last one right here, there's some problems that we really can't do, and I'll come back to them in the next video. They're better explained, and I'm not sure why, I did this with other instructors, these supplemental notes. I'm not sure why we put these in here prematurely. So A we're gonna come back to, C we're gonna come back to, E we're gonna come back to, H we're gonna come back to. All the other ones we can do, because what's the cosine of negative 60 degrees? Well, that's right here, backed off 60 degrees. Now, remember, all students take calculus, so my cosine's going to be positive. If I think about the cosine of 60 degrees, well, I would think, well, I know the sine of 30 degrees is 1/2, so the cosine of 60 degrees would also need to be 1/2 because they're co-functions of one another. And quickly I get a 1/2 with the appropriate sign. Tangent of 420, if you take off, there I go again, if you take off 360 from the 420, I'll try to be really careful. If you take off 360, that's going to leave you with the tangent of 60 degrees. That's right there in that first quadrant, tangent of 60 degrees. The sine of 60 degrees is √3/2. The cosine is 1/2, like we saw just a moment ago. So that means my √3 is going to be up top, and I'm going to have a nice square root of 3 coming out. Tangent of negative 45 degrees is right here, 45 degrees, halfway through. All students take calculus. It's going to be negative. So we're going to have a negative sign, and that's going to be a -1. And then cosecant of negative 60 degrees. Where is that? Well, the cosecant of negative 60 degrees is here, 60 degrees into it. All students take calculus. So that cosine and secant are going to be positive here, so cosecant's going to be negative. And what's the cosecant of negative 60? Well, that's related to sine. So sine of 60 degrees is √3/2. And cosine of 60 degrees is 1/2. And if I look at the cosecant, I really only needed this one, so I got to flip that one. So that's 2√3/3 rationalized. And then coming over here, cotangent of negative 30 degrees. All students take calculus. Okay, so it's going to be negative, and it's going to be a 30-degree angle. And so I got to think myself through this. Cotangent is cosine over sine. If tangent sine over cosine, and I know cosine of 30 degrees is √3/2 divided by sine. That's going to leave my √3 up top, so this is going to be a negative √3. And cosecant of 45 degrees. Well, I know that sine of 45 degrees is √2/2, so cosecant of 45 degrees is just a nice √2. And so you'll find language to talk yourself through it. Be patient, but be persistent with it, right? Do it a lot. So make sure you memorize these angles as best you can. Well, as soon as possible. I know you can get them all memorized. All right.